Well, Kori, I don't know about you and everyone else, but I'm super pumped to see you bring this all together.
I hope it meets expectations. It's
Hi, everyone. Bringing us all back together for the last real session of the day, where Kori's going to show us all these different components are assembled, and then we don't need to have a long wrap up at the end, but I do want to be available in case people have feedback, questions, discussion at the end of the day, and we'll just do a quick summary of what's happening tomorrow after Kori's presentation. So I think with that, Kori, you can take it away.
great. Thanks for sticking with us here to the bitter end. Hopefully this will be informative. So we're going to put the pieces together and to calculate veg departure for this sage steppe ecosystem. You can see how that comes together. You've kind of seen a preview of how this is going to work. So it shouldn't be new, but hopefully will be interesting. Again, I'll be doing a little bit of PowerPoint, a little bit of on-screen demo, and a little bit of Excel exercise. And so you can hopefully follow along with those files or follow along on the screen. The goals of this session are to calculate veg departure for the sage steppe biophysical setting on this particular landscape, the Saylor Creek Air Force Range. We'll very briefly look at some considerations for how you present vegetation departure, and then we'll explore the impact of different summary units. My take-home messages that I hope you will get from this session are that the departure display matters. It'll influence how people interpret vegetation departure on a landscape. And then the summary unit really matters. And you've heard that before, because you're going to get a different departure score with a different summary unit. Going back to our departure workflow here, we have estimated reference conditions, or at least you've seen how that's done. And I'm going to show you one way to get the exact reference class percent. In the last session, we calculated the current class percent. So we're going to put those together in a spreadsheet exercise and calculate veg departure. If you'd like to follow along, you can open up the spreadsheet that says exercise calculate VDEP. And there's a second spreadsheet in the folder called LANDFIRE CONUS reference condition table. Those are the spreadsheets we're going to work with. And so you can go ahead and bring up the reference condition Excel spreadsheet if you'd like to follow along. As I said, there are a few ways to get the reference class percent. Randy showed you the model. You could actually rerun the model if you wanted to. The model's stochastic, so your reference conditions could vary a little bit from what we calculated, but they'd be very close. You can go to the description document. The percents for the reference conditions are found there. And you can go to this thing called the reference condition table, which is available online and gives you the reference conditions for every single biophysical setting in the US. This one's for CONUS. There's a different one for Alaska. So the first thing I'm going to do is add filters so that we can filter for our biophysical setting of interest. And maybe I'll just zoom a little bit here. Let's see if we can do 125. That's better. Okay, so we've applied a filter. And now I want to look for my particular biophysical setting of interest. So I'm going to filter on column C, model code. And remember, we're looking at model 11250. So I click select all, everything's unselected, and then I'm going to go about it's about halfway down. 11250. We want the one that starts with zone 6 _6, 11250 _6. When you have selected that, what you get are the reference succession class percents for this biophysical setting. So here we have Intermountain Basins, Big Sagebrush Steppe, and we have the reference percent for classes A, B, and C. Notice there's nothing in D or E because those states weren't defined for this particular biophysical setting. Okay, so here we have reference percents. So I'm going to go back to the exercise worksheet. This is exercise calculate VDEP. And I'm going to put in these percents for the reference percent. We're working here starting in row 2 with the summary unit Saylor Creek Air Force Range. We'll look at some other summary units later. All right, so I'm going to enter the reference percents, and Class A is 25, Class B is 49, and Class C is 26%. Uncharacteristic exotic and uncharacteristic native will have 0 for the reference percent. And then the current conditions we calculated in the last exercise. So you can look those up if you happen to have that table open still, or you can just let me read them off to you. So S Class A and the current percent, we calculated that as 48%. I'm just rounding here. B was 0.02. I'm just going to leave that as 0. That's effectively 0. And Class C, I'm going to round up to 3%. For uncharacteristic exotic, I'm going to round that up to 35%. And uncharacteristic native, I'm going to call 14. And you'll notice that I just did a little bit of rounding there. How do I put in a sum? I hid some of my stuff. But anyway, if you summed this, I think it sums to 100%. And so I rounded a little bit to make that happen. Okay, you've got your reference percent and your current percent. So your job then is to enter the similarity in column F, which will then populate, I think, if this works right, sum of similarity in G and veg departure in H. And so I'm going to give you time to do that now. And what I'd like you to do is go ahead, do the calculation and maybe make a nice graph of reference and current percent. So go ahead, take some time to do it on your own. I'm going to just go ahead and continue to share my screen and work through it right here. So if you'd rather follow along, you can just follow along with me. Feel free to speak up if you have any questions. I think everybody's kind of seen the math, but it's nice to have run through those calculations in a real world example. And now you've also seen this thing called the reference condition table. So you know it's really easy to get reference conditions for any biophysical setting you want without having to open up a Word document and pull them out by hand or something like that. Okay, the next thing that I would like to discuss is this issue of veg departure display. And my point here is that depending on how you display your departure results, it can be misleading. And so here I'm just showing when I wanted to produce this exercise for the Saylor Creek Air Force Range, I just downloaded this extent of LANDFIRE data. So that's what this square represents. It's just what I downloaded. And the issue here is that departure, the way we measure it in LANDFIRE, is for the extent of a biophysical setting. But when you look at departure, as I have it mapped here, so what I'm showing is the polygon for the Air Force Range, and then vegetation departure is the raster underneath. It's misleading because you can't actually see the biophysical settings boundaries. So this red down here in the south could be a different biophysical setting than this red up here in the north. And there could be very different reasons for their departure. And actually, maybe they're the same biophysical setting, but I don't know because I don't know this landscape very well. The other thing is that it makes people think that this specific point on the landscape might be highly departed or that it's in good shape. So you could zoom into, you know, a little group of pixels here and say, oh, this place is really in bad shape. Maybe there's actually no management actions you would take there. Maybe it's departed because somewhere else on the landscape, there's a problem in this biophysical setting, such as tree encroachment or invasives. My caution is to be careful with how you display departure because it will influence the message that users take away. I would also make the argument that it's both easier to understand the tabular data and that there's a whole lot more information in the tabular data. So there are reasons to display a departure map, but often there's a lot more information to be had in the tabular data. The next thing I'd like to do is hit on this issue of summary unit just a little bit more. And so first we'll do a short exercise, and then I'll go over some guidance in the guidebook, talk about some issues, and then we'll wrap up, and that'll be that for this lesson today. And then we'll wrap up the workshop for the day. Okay, so let's look at how summary unit can affect your departure results. So here on this particular landscape, again, the Saylor Creek Air Force Range, rather than calculating departure for the extent of the Air Force range, like we did in our succession class exercise, you might want to use a more ecologically meaningful unit. And here I'm displaying in blue all the HUC-10s or hydrologic unit codes that intersect this particular landscape. So I'm going to give you some values for the succession class amounts on two different HUCs that intersect the Saylor Creek Air Force Range. One is Browns Creek. That's this HUC that's occupies most of the central part of the range. And then the second one is this Pothole Creek that's on the eastern side of the range. So if you, let's see, if you go back to your exercise worksheet, you'll see that you have the Browns Creek HUC as a summary unit in row 9 and the Pothole Creek summary unit on row 16. And I actually already calculated current percents for you, and I've put them into the spreadsheet. Your job is just going to be to copy down the reference percents, which don't change. They're the same as the reference percents up here for Saylor Creek Air Force Range, because the reference percents apply to this entire biophysical setting across its range. So they don't change when we go to the HUC summary units. And so the idea here is that we're going to look at departure for different summary units and examine how departure might differ across summary units and the reasons for that departure. So take a couple of minutes and calculate departure for Browns Creek and Pothole Creek. You can do that on your own, or you can just follow along on the screen with me, and then we'll come back together. If you have any questions, just give a shout out. What I'm hoping you'll see is that whether you're looking at the Air Force Range polygon or the different HUCs, this is a really departed biophysical setting, but it's less departed on Pothole Creek in the Pothole Creek HUC than other places. It's still pretty highly departed. But the reason for that departure can differ. So on the Air Force Base, you've got an issue with exotics, primarily. Over a third of the landscape is in exotics. And you also have a problem with tree encroachment. And if you get past the uncharacteristic, you've totally lost S-Class B, which should have occupied half of the landscape under the reference condition. On Browns Creek, the primary issue is uncharacteristic exotic. There's nearly 50% of the landscape in exotics. And there's definitely some tree encroachment, but it's not nearly as big of an issue. Again, S-Class B, just gone. And Pothole Creek, again, uncharacteristic exotic and uncharacteristic native, but about a third is in this tree encroached state. So a lot of trees on the Pothole Creek. So there's some difference in the reason for departure depending on which summary unit you use. You'll notice across all of these, the theme that S-Class B is gone, nearly. We're just not mapping it. And so I think that perhaps that's true. Maybe it's really not there, but also because I don't know this landscape very well, I do wonder about the rules. And remember that S-Class B is very narrowly defined. I think it was 10 to 19% shrub cover. And so it makes me wonder, is it possible that we're not picking it up? So Louis, do you have thoughts on that? S-Class
yes,
B?
that is correct. That should the B class should be between 10 and 20, especially in sagebrush steppe. It's a very grassy system with low cover of natural Wyoming sagebrush in it. The map, you should be able to pick it up with Landsat, but of course that's a short interval for Landsat. Anything that is below 10% in Landsat is a little bit more difficult to do than, this would be easy, for example, probably easier in Sentinel or other platforms. So, but that's the correct value. B should be the dominant class, and it should be very herbaceous with 10 to 20%.
And do you think that it's largely gone from this area of the landscape today?
Yes. Okay. Yeah. What is surprising is that this was fire, and was wondering about why the C class, which is a shrubbier one, is still present, but that's, that could be an accident of topography and has nothing to do with logic or anything profound.
Mm-hmm.
Yeah. No, that makes sense to me.
Okay.
This is, in case you guys don't know, if you look at the map of cheatgrass distribution in the Snake River Plain, there's very little native vegetation left anymore in the Snake River Plain. So
yeah,
this is perfectly acceptable, as well, not acceptable, but expected.
Yeah. So the departure is matching expectations. Okay, something else to point out here is that we could compare this to a different summary unit. We have 3 different summary units here. A 4th summary unit is the one that LANDFIRE uses. And so that is shown here. Remember, let's just go back here. This is the whole extent of this particular biophysical settings model. So LANDFIRE is going to calculate 1 departure score for every orange pixel here. And when we did that in our 2020 version, we got a departure score of 56%. 56% departed, which is quite a bit less departed than what we were showing for the 2 HUCS and for the Saylor Creek Air Force range. And this demonstrates an important characteristic of vegetation departure to be aware of. And that characteristic is that as your assessment area gets larger, you will often see a decrease in vegetation departure. So that's something to think about as you're defining your summary unit. Let's dig a little bit deeper now into summary unit and hopefully offer you some guidance. So we've issued a lot of warnings about summary unit, but what are you actually going to do about it? This is the guidance from the FRCC map book. What they're saying, the Fire Regime Condition Class Guidebook, which we linked to earlier, and it's also linked to in my PowerPoints. what they say is that the summary unit is relatively large, it should be contiguous, and it should be big enough to exhibit the full range of successional states or disturbance regimes. And if you get a summary unit that's too small, you're likely to get inaccurate results, which could lead to planning errors. If you get a summary unit that's too large, you're not going to be able to discern changes in departure, and you might wash out the impact of treatments or other disturbances. The other piece of advice they offer is that an ecologically based summary unit is probably preferred. And they then go on to offer some suggested size ranges based on the historical fire regime. The sage steppe biophysical setting is what's called fire regime group 4. That means it's dominated by replacement severity fire at an interval of 35 to 200 years. For this biophysical setting, they would recommend an assessment area in the range of 20,000 to 500,000 acres. Now, when we look at, I'll escape from here, the Air Force range itself. Let's just look at the Air Force range. This particular landscape, the outer polygon is just over 111,000 acres. So size-wise, it fits in within the guidance that was given. But there's a couple issues. It's not really an ecologically relevant unit, first of all. And second of all, it has these interior, kind of this checkerboard stuff. When I summarized conditions for this landscape for our exercise, I dissolved. So we just used the outer polygon boundary, and I didn't take out these little interior squares. So I didn't use an ecologically relevant landscape unit, but I made it a little bit better by at least taking the outer boundary and dissolving these interior exclusions from the Air Force range. Okay, so when you look at your HUCS, these HUC tins are within that size range as well. So they would be appropriate summary units and more ecologically relevant than the boundary of the Air Force range. And as we've stated before, the summary unit that LANDFIRE uses is going to be shown here in orange, and it exceeds the size of the recommended range. But we had a reason for doing that, which is that we're a regional and national level program, and we wanted to show departure at a regional and national level. But it's a really good thing to consider, and one reason why you might want to refine LANDFIRE's vegetation departure for a smaller landscape. Okay, I am going to wrap up here, just bringing it back to our messages. Hopefully you've seen that the display can really influence how people think about departure, and it could actually lead to some misinterpretations sometimes. So you want to consider carefully your audience and how you present departure. And then again, as we've mentioned many times, the summary unit really matters, and it will change your departure. So you want to think carefully about that. I put a couple of resources here, the Fire Regime Condition Class Guidebook. That's where I extracted the information in the slides that provides guidance on summary unit, and then also a link to the LANS paper, again, which you've seen a couple of times. So with that, I'll stop talking. I'd love to take questions, or if anyone has some examples they'd like to share of how they dealt with a summary unit issue. I'm sure others have some experience that they could share on this. So please feel free to unmute and share or add something to the chat.
Kori, I have a question for you. In this example you had in the current conditions, some situations where you had 0 and the current percent, like succession class B was 0 across the different summary units. do you see that very often where where LANDFIRE maps effectively a 0, even with a little bit of rounding? And I'm curious if others run across this as well.
I'd have to go back through the data. I've definitely seen it. I don't know that I've seen it a lot, but I've definitely seen it. It's really hard to get an absolute 0 because we map the entire nation. You get a little bit of everything, but effectively 0. I've definitely seen, and I wonder if Paul's still on here. Paul maps succession class for LANDFIRE, and he might.
I'm here.
Yeah. Do you have anything to add to that, Paul? Have you seen it where you just don't map succession classes for a particular biophysical setting?
Usually some of those can come up as NA, but yeah, I don't believe so. I think it usually all just comes through.
Okay, but maybe in a small proportion.
Right.
Yeah, in the Northeast, I see that, for example, with in the Northern Harwoods, the late close succession class, it's really common that I'll get 0. And I think a large part of that is very real because of, basically logging over the years. But then also part of it is that in the succession class, and Kori hinted at this, the succession class, the cutoff is around 75 meters. No, 75 meters, 75 feet or 25 meters, I think it is, that goes on to that succession class D in this case. And I think when you look across the average of a pixel, LANDFIRE might under map height, or at least it seems that way sometimes. And so we might not pick up some of those taller succession classes. Another thing that happens is, in my part of the world, you might have 1 or 2 white pines that stick out in that 30-meter pixel, but that's not going to change the overall height value. So to me, that's a place where it's a good time for you to go in and look and see what's going on. If you get a 0, it's kind of a good data check to go in and figure out why that is.
For sure. You always want to gut check your calculations, especially if you've done the S-classing by hand. And I know Amy pointed out that there's a minimum function in Excel, which would help automate calculating similarity, which is another good way to help prevent error. Go ahead, Paul.
I'm not sure why you get 0s, but I'm not sure if this would matter, but when you folks do your calculations, do you just do small sections like what you were showing, Kori, for this exercise? Is that what you do?
I do think when I have
small parts of the
departure, it's almost always for a smaller landscape, a smaller extent than what LANDFIRE does.
Right.
So yes, I think you're right. It'd definitely be a reason why.
Because usually every time I do it, it's just all of CONUS. So I think my odds of running into a 0 is probably pretty tiny, which is why I never see that.
Right.
Or I do all of Hawaii and Alaska, No.
Yeah.
Just that changes, yeah.
Any other questions or comments about anything from today?
Was the question, do you see 0s in your departure analysis?
And
departure, sorry, go ahead.
0s and particular succession classes for the current.
Yeah, I mean, we did this for BPSs in our region. We see lots of 0s or near 0s, but that's because we have a lot of type conversion and departure and so either uncharacteristic, native, or exotic because of type conversion, and because we've got a lot of blobs in those middle classes and not things in some of the others. So for us, it's sort of showing us where these things are.
Yeah, and where are you, Amy? I forget. I think you said earlier, but
sorry, I did, but that was many discussions of food ago. I'm in the Southeast region. I'm based out of Atlanta, so stuff like what we have behind me, which is a longleaf pine stand. So thanks for showing up for the hardwoods and the shortleaf pines and things like that. That was really great to see.
Yeah, I could so see that now that you mentioned that, Amy. I could totally imagine you get some zeros or near zeros across longleaf pine, for example.
Right, especially if what you've got as your current condition is a type conversion to a loblolly pine stand or something like that.
Yes.
Any other
Louis.
questions or thoughts? Or
Yes.
Yeah, Louis.
We often are early successional class. It's often short duration, so the likelihood you will see it just because it's a short duration is automatically, just by lottery system, is less. With Landsat, it's very hard to detect cheatgrass, for example, at less than 10% cover. So if your A class is invaded, like with cheatgrass, like in the West, when we do our own remote sensing, we detect that with high resolution imagery. But with Landsat, that would show up probably as 0 infestation. So you may have A class. So with LANDFIRE data, you're more likely to have non-zero observed for like an A class. But when you do your own remote sensing, you're discovering that cheatgrass is everywhere. So by definition, that goes to uncharacteristic class. And if it's a short duration class, riparian systems also have early successional short duration class grasslands and some of these systems. So the likelihood you'll ever observe it is just by lottery, just less. So you're likely to hit zeros. But if you have national data, it would be unbelievable that you would have true zeros at large landscapes. I mean, it would have to really require something special. So the smaller your landscape, the more likely you have that, unless you have a completely, I can imagine these eastern landscapes that are completely transformed, but in the West, it would be uncommon.
Yeah, you raise a good point. And the cheatgrass example is a good one where perhaps if you were doing a local assessment, maybe you'd bring in some ancillary data. There are really good maps of annual herbaceous cover that are put out by different programs. There's some links in the chat if you scroll back a little bit, because Anna asked about this earlier. So there are some good products where you could get a better estimate of cheatgrass cover at lower levels. So if you felt like, 0 to 10% cheatgrass, like that was really important to class as exotic, you could bring in that ancillary data and stamp that in. And then, you'd have a better representation of uncharacteristic on your landscape. Uncharacteristic exotic, that is.
All right. Well, thanks, everyone. Unless there are other questions or comments about today, which we'd be happy to address, I will do a quick summary of what we've seen today, what will happen tomorrow, and soon after. Today, basically, Jim, Kori, and I went over the basics of vegetation departure and the LANDFIRE inputs for that. And then Kori kind of brought it all together, showing us how it's calculated in kind of a manual tabular way, and explored the consequences of scale. So hopefully that empowers you to do some vegetation departure work on your own, or at least feel like you're a little bit more conversant in it if you want to reach out to us for any kind of help on vegetation departure mapping. Tomorrow we call it a deep dive into departure. You'll have less of Jim, Kori, and I, and more of others, which will be fun. We'll have a presentation on making a custom succession class layer. So this is one of the more common adjustments I see, where somebody has their own input, but they need to kind of tie everything together. So they do manual S classing, sort of like Kori demonstrated today, with some additional information. I will do an R demo. I'll show you some code and some outputs that I've put together. It's almost more around the communications piece, around LANDFIRE data in general, and then around the departure idea. Then we'll have Jean Lorbert will come in from the Appalachian Forest area to talk about how they create vegetation departure using some local disturbance data to update some of the inputs. And then Louis, Sarah Beyer, and Kevin from the Nevada chapter of the Nature Conservancy are going to talk about a management-driven research development of landscape conservation forecasting, sort of building out on the vegetation departure to bring in some management concepts. And then we love to queue up a discussion tomorrow. I know it'll be late in the day, but we will have time for that, and then Jim will wrap it up. So hope to see you all tomorrow. And again, please reach out to us with any feedback you have. You can also reach out to Jackie, and she can make that feedback anonymous if you feel more comfortable with that. And tomorrow we'll also be launching a poll for you to get some feedback. Yeah, Jackie says, send me the gripes because we want to improve, but not about box. That's fair. All right, with that, everyone, I guess we'll call it a wrap. I'll be here as well. I'll stick on with Kori if you have anything you want to chat about. Otherwise, feel free to sign off and enjoy the rest of your day.